Hi everyone, welcome back to Chem Help ASAP. In this video, we are going to be working some problems based on the mole concept. Now, we're first going to lay a little foundation and we're going to do some problems using the dozen concept because we're all a little more comfortable with that. Then we're going to go into the mole concept and use Avogadro's number to convert between moles and either atoms or molecules. Now, to do these problems, it is helpful to have your calculator ready and make sure you're comfortable putting scientific notation and using scientific notation in your calculator as we do these problems.
Okay, starting with our dozen concept. My first problem reads, how many dozen eggs do I have if I find 24 eggs in my refrigerator? Now you've just done this problem in your head, but let's see how we actually work it out mathematically. I start with what I'm given. Here are my 24 eggs. I know that there are 12 eggs in a dozen, so I'm going to use that as my conversion factor. I set it up like so. Then my eggs cancel. I'm left with dozen eggs. And here is the answer that you have already calculated in your head. You have 2 dozen eggs in your refrigerator. Now I know this seems like a lot of work for a very simple problem, but we are trying to build skills that we will then use when we talk about the mole concept. Let's look at question number 2. It reads, I need 2.5 dozen cookies for my class. How many cookies should I make? Again, I start with what I'm given. I am given 2.5 dozen cookies. Still using my same conversion factor that there are now 12 cookies in 1 dozen cookies. I set up my problem like so, again, making sure that my dozen cookies cancel, and I'm going to need to make 30 cookies. Again, you did this problem in your head without having to set it up like this, but we are building skills here. One thing I want to point out between these two problems is notice I'm still using the same conversion factor, that there are 12 items in a dozen of whatever that item is. But notice how the conversion factor is flipped depending on what information I start with. Am I starting with my item or am I starting with my dozen items? Again, these are skills that we are going to transfer when we work on our mole problems. But we have 2 more problems where we're going to use our dozen. Problem number 3 reads, a new neighborhood is built with 120 houses. How many dozens of houses are in the new neighborhood? So I'm going to start with what I'm given. I'm given 120 houses. My conversion factor again is there are 12 houses in 1 dozen houses. My houses cancel. I'm left with dozens of houses, and we have 10 dozen houses. My last problem reads, in some places you can see as many as 150 dozen stars in the night sky. How many stars is this? Starting with what I'm given, 150 dozen stars. I set up my conversion factor so that the dozen stars cancel, and I have 1,800 stars are visible. Again, you can see in these last 2 problems, I'm still using the concept of a dozen being 12 items in 1 dozen, but I either multiply or divide by 12 depending on how my units cancel. One tip you can take to any kind of chemistry problem is if your units work out, then you have probably done the problem correctly. That's just a nice little thing to keep in the back of your head. Now on to our mole concept. So we are going to use the skills that we just built by using the dozen, and we are going to apply this to Avogadro's number. Now remember, a mole is a very specific number of either atoms or molecules. It is 6.022 times 10 to the 23rd. It works just like the dozen. We're going to do the same thing where we're going to make sure our units cancel, and that should get us to the right answer. So let's read the first problem. Most microchips are made using silicon. If an average microchip contains 0.16 moles of silicon, how many silicon atoms are on an average microchip? Just like we did with the dozen problems, I'm going to start with what I'm given. I am given 0.16 moles of silicon. Now I need to convert from moles of silicon to atoms of silicon. This means I need to use Avogadro's number. Just like with the dozen problems, I want to be sure that my units cancel. So I'm going to set up Avogadro's number like so that my moles of silicon cancel and I am left with atoms of silicon. Then of course you just do the math in your calculator and you get 9.6 times 10 to the 22nd atoms of silicon. Let's look at problem number 2. It reads, argon makes up less than 1% of Earth's atmosphere. How many moles of argon are contained in Earth's atmosphere if there are approximately 7.43 times 10 to the 41st atoms of argon? Okay, first of all, I want to point out that saying that argon makes up less than 1% of Earth's atmosphere is just extra information for you. We are not actually going to do any math with that 1%. So what I am starting with is the 7.43 times 10 to the 41st atoms of argon. I want to convert from atoms of argon to moles of argon, so I'm going to use Avogadro's number. Again, just like in our dozen problems, we want to make sure that our units cancel. So I'm setting up Avogadro's number like so, making sure my atoms of argon cancel. I am left with moles of argon. Now I simply do my math, and I find that there are 1.2 times 10 to the 18th moles of argon. Just like we talked about with the dozen concept, if you look at these two problems and you look at Avogadro's number, you see that the numbers themselves don't change, but what you put in the numerator and the denominator do change depending on what units you want to cancel. This is why it's so important to write your units down, because it's very easy to flip a conversion factor like this and end up dividing where you need to multiply or multiplying where you need to divide. But your units will help direct you.
The key takeaway from these problems is to remember that the concept of the mole is based on a number, just like the concept of a dozen is based on a number. I hope you found these problems helpful. Please let me know in the comments below if you'd like to see other problems worked, and thanks so much for watching.